All right, so an ordinary annuity. An ordinary annuity is a sequence of equal payments made at equal time intervals. The value of an annuity is the sum of all the deposits and all the accrued interest. If P dollars, so P is a number of dollars, is deposited into an account at the end of each of n compounding periods, each year for T years at an annual interest rate of R% per year, then the value of the account A, that's the future value of the account, is given by, and here's the formula for an ordinary annuity. So we have here the A, which is the uh, value of the annuity or the sum of all the deposits. The value of the annuity is A, and it's equal to P. P is the deposited amount, so we're making deposits uh, at the end of each of n compounding periods. So we're making n deposits. N is the number of deposits we're making, and P is the size of the deposit, and the interest rate is R. So here's the formula for it, and here's an example we can use using this formula. All right, so we're being asked here to look at deposits of $100. So those are the individual deposits. I think the letter that we're using for the individual deposits, we're using P. P is the individual payment amount. 100, you're depositing $100. And it's made at the end of each month. So it looks like the compounding period is each month. And it specifically actually says compounded monthly. So it's deposited at the end of each month into an account that pays 10%. That's the interest rate. The interest rate is 10%, but we're not going to leave it as 10%. We're going to write it as 0.1. 0.1 is 10%. Compounded monthly means that n is equal to 12. Monthly compounding, you're compounding 12 times per year. It says, what will the value of the account be after 15 years? So the time frame is 15 years, and what they're asking about is the value of the account. That's the unknown here. So the value of the account. So that's the formula we're using right there. Oops. So this formula right here, uh, let's just grab it. All right, and let's plug everything in. So, all right, what do we have? We have A is what we're on the lookout for. P is 100. P was 100, right? Yep, and then it's 1 plus R, which is 10%, 0.1, over N, which is 12, raised to the power of NT, which is 12 times T, which is 15, minus 1, and that's all divided by, R, which is zero point 0.1, over N, which is 12. So this calculation will tell me how much money I will have 15 years into the future if I keep making $100 deposits into an account that pays 10% monthly. So we would just do these calculations here. Let's see here. Okay, so let's see. This then is 100, and then this gives me 1.008 with repeating 3. And let me see. This is 180, and I'm going to subtract 1 away from that exponential. And then this is just 0.008 with that same repeating 3. So we just have to figure out what all this is equal to. Let's see. Uh, So we were gonna raise power. After you raise to the power, subtract 1, multiply by 100, and divide by 0.0083 repeating. And what I get here is that the value of this annuity is $41,447. And that's how we calculate the value of a ordinary annuity.